The objective of the following case is to introduce and demonstrate new capabilities in In-Situ Sim version 3.0. These functions include the Key Performance Indicators Manager, where our user can monitor selected variables, the cloning feature, where our user can have multiple cases that are independent of each other, but can be used to compare the selected KPI values across them, and an introduction to a new process block, natural gas decarbonization. First, let's take a look at the KPI Manager. This can be accessed from the bar on the left side. Go to the third icon and select KPI Manager in the menu. This will bring up the KPI Manager. Here, you can select the KPIs of interest to you and add them to your selected KPIs. This is done by selecting the category of interest, which will display the KPI provider, and then the available KPIs associated with the former two selections. From the available KPIs, a user can select and add the ones of interest to their selected KPIs by clicking the plus sign. Selected KPIs can also be removed by selecting the ones that are no longer of interest to the user in the selected KPIs and clicking the minus sign. Let's build a case to show the comparison function of the KPI Manager. Here we have the base case which we will run. Now let's take a look at the cloning function within In-Situ Sim to clone the base case to build a comparison template. At the top of In-Situ Sim within the green bar, there is a pencil icon. Click on this icon. This will show a user all the available cases currently active. Here a user can name their current case and clone that case by clicking the clone option. In-Situ Sim will then prompt the user to name the clone case. Name and click clone. Back in the work environment, a user can view and switch between all their cases by using the drop-down menu beside the pencil icon. In the cloned case, base case V2, let's incorporate the new natural gas decarbonization process block. In In-Situ Sim, the natural gas decarbonization block is based on partial oxidation. The block removes the carbon from methane and generates hydrogen, which can be used in the OTSG. Natural gas decarbonization has two inlets, the first being natural gas. A portion of the natural gas will be used to provide heating for elevating the reactants to the reaction temperature of approximately 1300 degrees Celsius. The second is air, which is required for combustion. The two outlets include a hydrogen product stream and a combustion flue gas stack. The hydrogen demand in the block is dependent on the required hydrogen in the OTSG. For this case, I will be setting the OPEX and CAPEX values to 0. These values should be provided by the user. Let's run this new case. Now using the KPI Manager, we can compare KPIs of interest. Let's compare the direct GHG emissions and the natural gas fuel use of the two different cases. Direct GHG emissions can be found by going to the Report Manager, GHG Emissions, and Direct GHG. Natural gas fuel use is found in Report Manager, Energy Efficiency, and Natural Gas Use. Now in the Global KPI tab, which is the fifth icon on the left, users can view bar graphs comparing the two cases in relation to the KPIs of interest selected. As seen, adding a natural gas decarbonization unit reduces greenhouse gas emissions by 51%, and overall natural gas use increases because natural gas is needed to heat the feed to approximately 1300 degrees Celsius.